question reads, ammonia is a weak base. It has a pKb value of 4.75. Calculate the pH of a 1.00 into 10 power negative 2 molar aqueous solution of ammonia at 298 Kelvin. And since it's at standard temperature, that's something we don't have to worry about. The first thing we need to do when we look at this question is obviously to write down the equation. So since it's an aqueous solution of ammonia, we would write an equation for ammonia with water, and since it's a base, it would dissociate into the ammonium ion as well as hydroxide. So the second step is finding the expression for Kb, or the constant, the equilibrium constant for bases. This is basically the product of the concentration of the products and divided by the product of the concentration of the reactants. Since H2O is a constant in this equation, we will not be putting H2O in this, and we'll just have ammonia in here. Step 3 is finding the Kb from the pKb, which works very similarly to how you find the pH from the concentration. So Kb is just 10 power negative Kb, or the anti-log. So 10 power negative 4.75 is 1.78 into 10 power negative 5. Note how the significant figures are maintained. They're all in 3 significant figures. So is the question, which is 1.00. Step 4 is getting an equation for the concentration of OH. The Kb, as we found earlier, was the concentration of NH4 multiplied into the concentration of OH divided by the concentration of ammonia. From this equation, we can see that the ratio of ammonia to hydroxide is 1:1. So we could just say that the multiplication of these constants, these concentrations, is going to be the same as the square of OH minus concentration. So when we move this equation around and try to find OH, you basically just square root the other side. And when you square root this, you get a value of 4.22 into 10 power negative 4 mole. Step 5 is finding the pOH, which is the negative log of the OH concentration. And after that, we find the pH, which is 14 minus pOH. So when you do those steps, you find a pH of pOH, of 3.37, and a pH of 14 minus 3.37, which is 10.63, which when rounded off to 3 significant figures, again, very important step, gives you 10.6. Alternatively, you could use the constant value for water to find the hydrogen ion concentration by dividing 1.0 into 10 power negative 14 by the concentration of OH that you just found. After that, when you find the negative log of that, you get 10.6. That's how you do this problem.